Okay, so today we're going to do the second lesson in partial fractions. And again, I want to start this by almost doing the reverse because we need to look at a thing called repeated factors in the denominator. Okay, and that's when we have something that looks a bit like this, when we have a factor squared in the denominator. So before we start, what I actually want to do is do the reverse again to show what type of thing we get. Now, if I wanted to combine these three fractions, it would be really easy to say, well, I just multiply the first fraction by the second denominator and by the third denominator. It'd be again, so for this next one, we'd have to multiply the middle fraction by the first denominator and the second denominator, and we would multiply the last fraction by the first denominator and the second denominator. And if we did that, we'd end up with a fraction that would be over x plus 1 times x plus 1 squared times 2x plus 1. But actually, if you look at these two, you'd end up with x plus 1 cubed. And that wouldn't be the lowest common denominator. Okay, so it'd bit like going back to year 7-8 work. If I said what is 1/5 plus 3/10, it would be a bit like using 20 as our denominator. We can, and it works, and it gives us the right answer, but it doesn't give it in the simplest form. So we don't want to do that. We want to think, what is the lowest common denominator that we can use? So I'm going to undo all of that, because that's not what we want to do. So let's have a think a little bit more cleverly about this. And let's actually think, what is my lowest common denominator? Well, obviously, it's got to have a 2x plus 1, because we've got that one in the third fraction. It's got to have an x plus 1 squared, because we've got that in the second fraction. But actually, if we think about now the first fraction, we've already got this factor of x plus 1, because this factor of x plus 1 is in here. So our lowest common denominator is actually 2x plus 1 times x plus 1 squared. So let's think, what do I have to do to make this my denominator for each of my three fractions? Well, if I look at the first fraction, I actually need an extra factor of x plus 1 and a 2x plus 1. And again, whatever you multiply the denominator by, you have to do the same to the numerator. Now, let's look at this middle fraction. What do I need to multiply this denominator by to make it the same as the final denominator that I want? Well, for that one, all I've got to do is multiply it by the 2x plus 1, because I've already got the x plus 1 squared. So again, whatever I multiply the denominator, do the same to the numerator. And then for the final fraction, again, I've got to make it the same as that end denominator. So I just need to times it by the x plus 1 squared and the x plus 1 squared. So what I'm actually left with is 2 times x plus 1 times 2x plus 1 from the first fraction, plus 1 times 2x plus 1 from the second fraction, plus 1 times x plus 1 squared from the third fraction. And then I'm going to tidy that up. So just write the denominator first. It's the easiest thing to write. Okay, what I would do is I'd probably expand this bracket in the first grouping from the first fraction. And if I expanded that, so I've got 2 outside, I've got 2x squared from the x times the 2x. I've got an x and a 2x, so I've got plus 3x plus 1. Then let's do the part from the second fraction, so that just becomes a 2x plus a 1. And if I think about x plus 1 squared, that's just x squared plus 2x plus 1. Okay, so what do we have? Again, now look at that first bracket. I'm going to have 4x squared plus 6x plus 2 plus 2x plus 1 plus x squared plus 2x plus 1 all over 2x plus 1 times x plus 1 squared. And when we tidy all that up, we get 5x squared plus 10x plus 4 all over 2x plus 1 times x plus 1 squared. Okay, so what we notice is if we have a fraction that looks like this, it can come from 3 parts. It can come from a part with a denominator of a single x plus 1, a part with the denominator of a x plus 1 squared, and the part with the denominator of 2x plus 1. So this is the type of question we're going to get. We're going to get split this into partial fractions. Okay, so I know I am going to have a denominator of 2x plus 1, but I'm also going to have this. Now it might be, first thing a lot of people would do is they might go a plus 1 squared plus b over 2x plus 1. That's not the right thing to do, because we've got to remember when we have this repeated factor in the denominator, it actually creates 2 parts. Okay, so we have to have the part where you've got the single factor, you have to have the part when you've got the repeated factor when it's squared, and then in this case we've got our third part because we've got our other factor which is 2x plus 1. So when you have a repeated factor, it's really important you remember you need the x plus 1 and you need another factor which is x plus 1 squared. Okay, and then we carry on as normal, but you do have to think a little bit more clever. I need to make this denominator the same as this denominator. So what do I have to do to this denominator to make it the same? Well, I've got to multiply it by an extra x plus 1 and the 2x plus 1. And again, whatever you multiply the denominator by, you have to do the same to the numerator. Right, let's look at the middle fraction. So I've got to make this denominator the same as this denominator over here. So now the only thing I need is a 2x plus 1. So again, whatever you multiply the denominator by, you have to multiply the numerator the same. And then the final one, so we've got our denominator on the end, we've got to make it the same as this denominator over here. So the only thing I have to do is multiply it by x plus 1 squared. So times x plus 1 squared. Okay, and now we go to this next line where we don't bother writing any denominators anymore because we can cancel through. And so we have the line 7x squared plus 7x plus 2 is equal to a times x plus 1 and 2x plus 1. We've got our b times the 2x plus 1, and we've got the c times the x plus 1 squared. Because people will ask me, how do you know what to multiply by? You've got to think, I've got to make the denominators the same as the original thing that you're starting with. Okay, and then we carry on as normal. So we say, well, let x equal 1, because that way we can eliminate that x plus 1 factor. So we've got 7 plus 7 plus 2 is equal to a times 0, which goes, plus b times, well, 2 lots of 1, sorry, it's minus 1. Sorry, so we should have, that should be a minus 7 there. So we've got 2 lots of minus 1 plus 1 and plus c times 0, which disappears. So we've got 2 equals minus b, therefore b equals minus 1. There's the first factor, or the first constant that we're looking for, not factor, sorry. Right. Second value that we're going to try. So let me just get rid of this. We're going to say let x equal, now again we want this 2x plus 1 to be 0, so x has got to be minus a half. So we've got 7 times minus a half squared plus 7 lots of minus a half plus 2, and that's going to be a, well, that factor is going to go to 0, b, that factor is going to go to 0, plus c times minus a half plus 1 squared, because remember you got that little squared on that. So put it in the calculator. So you've got 7 quarters minus 7 halves plus 2, and you end up with a quarter is equal to, now minus a half plus 1 is just minus a half, and if you square that you get a quarter c, so therefore c equals 1. And then the final one, let's get a different colour, we'll have blue. Because I haven't used it, I'm going to say let x equal 0. So I would have 2 equals a. Now, I'm not going to work this out. I'm not going to write it out rather. But if I look at the 2 up here, I've got x plus 1 times 2x plus 1. Well, if x is 0, that is just going to be 1 times 1. Plus b times 1. Plus c times 1 squared. So, you can tell I've done this video before. So what do? We end up with 2 is equal to a plus b plus c. Now, let's go back. My b was minus 1. My c was plus 1. So guess what? A equals 2. So let's do my solution. So I've got my 7x squared plus 7x plus 2 all over x plus 1 squared times 2x plus 1 is equal to 2 over x plus 1 minus 1 over x plus 1 squared plus 1 over 2x plus 1. Okay. Right, I'll do a second example. Okay, because sometimes people don't realise this is the same, but we've got this as our factor, x, in the denominator, but it's a repeated factor because it's x squared. So that just becomes a over x, the factor as it is singularly, plus b over x squared when it's repeated, plus c over 2x minus 3. And again, it's all about making this denominator the same. So one step at a time. I've got to make this denominator match this denominator. So what do I have to do? I need an extra factor of x and a factor of 2x minus 3. Right, I've got to make this denominator match this denominator. So what do I need? Well, in this case, I just need the 2x minus 3. And then the final one, I've got to make this denominator match this denominator. So I just have the x squared. And remember, whatever you multiply the denominator by, you have to multiply the numerator. So what you're left with is 12x squared minus 9x plus 9 is a times x times 2x minus 3 plus b times 2x minus 3 plus c times x squared. Okay, and this is the equation that we need to then find out what a, b and c are. So nice easy one, this one. Let x equals 0. So I've got 9 is equal to, well, a times 0, so that goes b times minus 3 plus c times 0, that goes. So you've got b is equal to minus 3. Be careful there. It's really easy for people to accidentally say b is minus a third. So just be really cautious when you're doing these. It can be so easy to make little mistakes. Right, the second factor that we want to eliminate this 2x minus 3. So I need to use a value of 3 halves, 3 over 2. Okay, so I've got 12 times 3 over 2 squared minus 9 times 3 over 2 plus 9 equals, well, A, you're going to have a 0 factor there. B, you're going to have a 0 factor there. Plus C times 3 over 2 squared. Now, you'll probably shoot to your calculators to do this, but I'm going to show you without the calculator, because we've got 12 times 9 quarters. The 12 and the 4 cancel to give you a 3. So 3 times 9 is 27. Minus 27 over 2. So if you've got 27 minus 27 over 2 plus 18 over 2, because that's what 9 is. 9 is 18 over 2. So effectively, we've got 54 over 2, take away 27 over 2 plus 18 over 2. And that's going to give us 27, add 18, 27, 37, 45 over 2. Okay, so I'm going to remove all that and I'm just going to write the answer, which is 45 over 2 is equal to, I've got C times 3 over 2 squared, which is 9 over 4 C. Okay, again, try and do this without a calculator. At least do it first and then check. So I'm going to times by 2, so that's going to cancel with that. And we're going to have 90 divided by 9, so I'm going to get C equals 10. So I've got B is minus 3, C equals 10. I've used the value of x equals 0, so I can't use x equals 0 again. So we're going to use x equals 1, because that's always quite a nice one. So we've got 12 minus 9 plus 9 equals A times 1 times 2 times 1 minus 3, so that's times minus 1, plus B times minus 1 plus C times 1 squared. Okay, so you've got 12 equals minus A minus B plus C. Let's put those values in that we'd worked out. So we had minus A, because we still don't know what A is. Now minus B. B is minus 3, so I've got minus 3. So that becomes plus 3 plus 10. So 12 is minus A plus 13. So guess what? A equals 1. Okay. And now I can write my final solution. So let's just go up there. So I've got 12x squared minus 9x plus 9 over x squared 2x minus 3 is equal to 1 over x minus 3 over x squared plus 10 over 2x minus 3. Okay, right. Have a go at those 4. Press pause and I will show you the solutions when you're finished. Okay, so first one, here we go. Again, you've just got to think about this idea of making the denominators the same. So how do I make this denominator the same as that one? I need to multiply it by x and x minus 2. How do I make this denominator the same as this one? I just multiply it by x minus 2. And the final one, how do I make this denominator the same as this one? I've just got to multiply it by the x squared. So hopefully you should get that first line. Substituting in x equals 0, x equals 2. And then the final one I chose was x equals 1. And then hopefully you got the answer that it was equivalent to 2 over x minus 1 over x squared plus 3 over x minus 2. Okay, so again, second one. How do I make this denominator the same as this one? I need an extra x plus 1 and a 2x minus 1. Make that the same as this. I just need the 2x minus 1. And make that the same as this. I just want the x plus 1 squared. So there's the first line. Use the substitution of x equals minus 1 to get rid of the first factor. Use the substitution of x equals a half to get rid of the 2x minus 1. And then because you haven't used x equals 0, it's always the best one to use as the final one. So you get a equals 3, and hopefully you got that fraction is equivalent to 3 over x plus 1 plus 2 over x plus 1 squared minus 4 over 2x minus 1. Right, now this next one is a bit different, and I didn't show you this example, but I just wanted to see if you could do it. Because it's just a repeated factor. There is no plus c over with this one because there isn't an extra factor. But the same for loss of 3 pi's. I've got to make this denominator the same as this one. So I've got to make the denominator under the first fraction the same as the original denominator. So all I need is an extra 2x plus 1. Now this second one's interesting. I've got to make this denominator the same as this one. Well, it already is. So some people sometimes write times 1, but you don't need to write that. It just stays the same. So it just becomes 4x minus 1 equals a times 2x plus 1 plus b. And again, using the substitutions, you just end up with 2 over 2x plus 1 minus 3 over 2x plus 1 squared. And the final one, I'm not going to necessarily explain this one. I'll just show it to you. Hopefully you got the first line. Use the substitution x equals 2, x equals minus 3. And because we haven't used x equals 0, we'll use x equals 0. And then you ended up with 2 over x minus 2 minus 1 over x plus 3 minus 4 over x plus 3 squared. Now, to come back to this original one, it doesn't matter which order you do this in, okay? I particularly just put the a under the first one. If it's repeated, I'll have that having the a and the b, and then the c under the third one. But if that one's repeated, I just tend to go in the order that they're written in the question. But it doesn't matter. The only thing that matters is that you have the 2 as the numerator to the x minus 2 denominator. You have the minus 1 as the numerator to the x plus 3 denominator. And the minus 4 is the numerator to the x plus 3 squared denominator. Okay, doesn't matter which order you write it in, as long as you match the correct numerator and the denominator together. Okay, a bit like last time, sometimes it's not obvious, but all you've got to do first with these is you've got to factorise those denominators. So in this case, the highest common factor of x cubed and 4x squared is x squared, so my denominator becomes x squared bracket x minus 4. And that then just tells you I've got a repeated factor of x. So it's a over x plus b over x squared plus c over x minus 4. And then you carry on as normal. So I'm not going to do these, but that's what you do. If we look at the next one, we just think I need to factorise this. So, well, what's common to all of them is I can take out a factor of x first. Okay, so I'd have x times brackets x squared minus 2x plus 1. But then I can factorise this to be x minus 1 times x minus 1. Okay, and so actually this would be written x times x minus 1 squared. So in this case, I've got a repeated root of x minus 1 squared. So I would write this as a over x plus b over x minus 1 plus c over x minus 1 squared. Okay, so again, finally, 3 for you to have a go at. Press pause and then I'll show you the solutions. Okay, so first one, you can take out a factor of x squared. So you're going to get a over x plus b over x squared plus c over 2x minus 3. Then hopefully, straightforward, x equals 0, x equals 3 over 2, and then finally x equals 1. And that's the solution that you get. Number 2, take out a factor of x and then factorise the quadratic. So you end up with a over x plus b over x plus 1 plus c over x plus 1 squared. Again, use your substitutions. And so your final answer should have been minus 1 over x plus 1 over x plus 1 plus 3 over x plus 1 squared. And the final one, slightly hardest but not too bad. Take out a factor of x, you end up with 4x squared minus 4x plus 1. Factorise that, we end up with 2x minus 1 squared. So we've got a repeated factor of 2x minus 1, so we end up with a over x plus b over 2x minus 1 plus c over 2x minus 1 all squared. And so again, using the substitutions, hopefully you had the same answer as me. Okay, so that's the end of this video, and I will see you next time when we'll look at improper algebraic fractions.